Hi class, let's discuss this figure. So this is the first figure that we're taking a look at in chapter 4 part 2. And so this is a pretty busy figure. There's a lot going on. And it's important to understand this figure, but you might look at this and get intimidated right away. So don't worry about, you don't have to memorize the numbers on this figure, okay? You need to understand the concepts. And so let's talk through it, all right? And so first thing I want to point out, and I apologize that this is in black and white, but if you're looking at this as a PowerPoint slide and it's in color, you'll notice that over here, all of these yellow lines and arrows, that's solar radiation. So solar radiation is represented by yellow, okay? And over here in red, this is terrestrial or Earth radiation, okay? So terrestrial or infrared radiation from the Earth, okay? Let's talk about this side with the solar radiation. We have seen this before, okay? So in chapter 3, we talked about the 3 fates of solar radiation as it passes through the Earth's atmosphere. We said that as solar radiation passes through the Earth's atmosphere, one thing that can happen to it is it can be reflected. Okay, so it could be reflected by clouds, it could be reflected by the surface, primarily snow, maybe water surfaces. And we had mentioned that 24% of incoming solar radiation as it passes through the atmosphere is reflected back to space. Well, look at here, 8 plus 16, there's 24% right there. A second thing that can happen to incoming solar radiation as it passes through the Earth's atmosphere is it could be scattered. Okay, so we've got solar radiation coming in, and part of that is scattered. We said that 7% of incoming solar radiation is scattered. So there's our 7% there. Combining these two, reflection and scattering, that's 31% of the incoming solar radiation. The third thing that could happen to incoming solar radiation as it passes through the Earth's atmosphere is it might be absorbed by gases in the atmosphere. And so here we've got incoming solar radiation, okay? Water vapor, dust, ozone, things like that will absorb 17% of the incoming solar radiation. Clouds will absorb 3% of the incoming solar radiation. So we said that of all of the incoming solar radiation as it passes through the Earth's atmosphere, 20% is absorbed by the atmosphere. There's your 20%, okay? So we've seen at least this part, this half of the figure before, okay? And we also stated that if incoming solar radiation is not reflected, if it's not scattered, if it's not absorbed, then it makes it down to the Earth's surface where it's absorbed by the surface. Okay, we also said that on a global basis, 49%, just slightly under half, 49% of incoming solar radiation makes it down to the Earth's surface where it's absorbed by the Earth's surface. There's the 49%. Okay, so again, we've seen this part of the figure. Okay, now let's look at the figure as a whole now, though, and pick out the points that we really need to understand. Okay, so what we're looking at here at the top of the Earth's atmosphere, there's a line drawn. Okay, and we're looking at all the radiation coming in and all of the radiation going out. Okay, so if you look what's coming in, it's only incoming solar radiation, which makes sense. And we assign a value of 100 units of incoming solar radiation to the amount of energy coming in through the top of the Earth's atmosphere. Then we also have to look at what's leaving the Earth's atmosphere. And as we mentioned, 24%, okay, 8% reflected by the surface, 16% reflected by clouds, 7% reflected by the atmosphere, or I should say scattered by the atmosphere back out to space. Okay, so that accounts for energy leaving the Earth atmosphere system and going out to space. Okay, and that's solar radiation that's being reflected and scattered. But we also have to take into account the infrared terrestrial radiation that is leaving the Earth's atmosphere. Okay, 9 units of that is energy that's emitted by the Earth's surface, which is 114%. Notice that 105 units of that infrared terrestrial radiation gets trapped or absorbed by the atmosphere. Okay, that's the greenhouse effect that we're talking about here. And the other 9, so 105 plus 9 is 114. So out of all of the energy that the Earth's surface emits on a global basis, only 9 units make it all the way out to space without being first absorbed by the atmosphere. We also have to take into account water vapor, carbon dioxide, oxygen, all the atmospheric gases emitting energy out to space. That accounts for 40 units, and clouds are a big emitter of terrestrial infrared radiation. Clouds will emit 20 units of infrared radiation. So if we add up 20 plus 14 plus 9 plus 8 plus 16 plus 7, add that all up, it equals 100 units leaving the Earth atmosphere system going out to space, and 100 units of incoming solar radiation. Okay, so we got 100 units coming in, 100 units going out, so there's a balance. Okay, and so that's our first point here. So if you might want to write this down, I don't know where to put this, but this is the first point you need to realize from this graph. Okay, there is a balance of radiational heat energy at the top of the Earth's atmosphere. Okay, 100 units coming in, 100 units coming out, and that shouldn't surprise us. Okay, because we've learned the 4 laws of radiation. Okay, and we mentioned that objects that are good absorbers are good emitters of radiation. Okay, and so we talked about black bodies in these terms, and so this is radiation law number 2. Objects that are good absorbers are good emitters. Okay, perfect absorbers and perfect emitters are called black bodies, and the Earth was an example of a black body. So all of the energy that it absorbs, it also, or all the energy that it receives, it also emits. Okay, 100 units of solar radiation coming in, 100 units of solar and terrestrial radiation leaving. Okay, so the Earth is a black body. All of the energy it receives, it also emits. Okay, so that's the first thing that you need to get from this figure. Okay. So now let's take a look at the Earth's surface. So we took a look at the top of the atmosphere. Let's look at what's going on at the surface. This one's way easier because there's only 3 things to look at. So what's coming in, what's being absorbed by the Earth's surface? We've got 49 units of solar radiation that we knew about. We've got 95 units of terrestrial radiation coming down from the atmosphere that's being absorbed by the Earth's surface. Okay, so this is the greenhouse effect right here. Terrestrial radiation being emitted by the Earth's surface, absorbed by gases, greenhouse gases in the atmosphere, and then a lot of that is re-radiated back to the surface. That's the greenhouse effect. So when we add up 49 and 95, we get 144 units of energy being absorbed by the Earth's surface. And out of that 144, 114 are being emitted, being given off by the Earth's surface in the form of terrestrial or infrared radiation. Okay, so when we add up 49 plus 95, 144, minus 114, we find that there's an imbalance here. There are 30 more units of energy at the Earth's surface than we should have. Okay, so there's something, let's not worry yet, but there's something wrong here in terms of there should not be a surplus. And that is our next point, is that literally there is a surplus of radiational heat energy at the Earth's surface. And that surplus is plus 30 units. Okay, so there are 30 units of surplus heat energy at the Earth's surface. Okay, so that's something to be concerned about, but let's finish the diagram before we start worrying anything about this. Okay, So there's a balance of radiational heat energy at the top of the Earth's atmosphere. There's a surplus of radiational heat energy at the Earth's surface. Okay, but now let's look in the atmosphere itself, and there's lots of numbers here to look at. Okay, so we've got absorption by incoming solar radiation. We've got, let me make sure I got my numbers here. So we've got 20 units of solar radiation being absorbed by the atmosphere. We've got 105 units of terrestrial radiation being absorbed by the atmosphere. So that's what's going into the atmosphere. What's leaving the atmosphere are the 95 units coming back down to the surface. We've got 20 units of terrestrial radiation being emitted by clouds, and 40 units of terrestrial radiation being emitted by the atmosphere, by greenhouse gases out towards space. Okay, so when you take 20 plus 95, okay, and then subtract, you got 20 plus 105, and then subtract the 95, subtract the 20, subtract the 40, okay, that gives you a net of minus 30 units, okay? And so as a result, what we find in the atmosphere itself is that there's a deficit of radiational heat energy in the atmosphere. There's a deficit in the atmosphere. Balance at the top of the atmosphere, surplus at the surface, and a deficit in the atmosphere. So again, if the Earth is a black body, there shouldn't be a deficit, okay? But there is. And kind of the good news, bad news. The bad news is there's a deficit. The good news is that it's a number that we recognize, that there is a deficit of 30 units of heat energy in the atmosphere itself. Okay? So we have a surplus of 30 units at the surface. We have a deficit of 30 units in the atmosphere. Well, you can probably guess what's going to happen. Okay? So there is a lack of equilibrium in the Earth-atmosphere system, and what I've always told you is that the Earth is always trying to reach equilibrium. The Earth atmosphere is always trying to reach equilibrium. Okay? And so as a result, what the Earth atmosphere system is going to try to do is to move that surplus 30 units of energy at the surface into the atmosphere where there is a deficit of 30 units. Okay? And how does the Earth atmosphere do that? That's why I covered this up for now. I almost feel like there should be a drum roll, but the Earth atmosphere system is moving that surplus 30 units of energy from the surface into the atmosphere where there's a deficit of 30 units through two different kinds of energy. Sensible heat energy and latent heat energy. Okay, and so that's where our discussion is going next. Is we're going to find out what sensible heat is, what latent heat is, and so when the Earth atmosphere system is moving 30 units of surplus heat energy from the surface into the atmosphere where there's a deficit of 30 units of heat energy, okay, that 30 units is taken care of by sensible heat and by latent heat. Okay, so that's where our discussion is headed next. What is sensible heat? What is latent heat? And how is that energy moved from the surface into the atmosphere?